Okay. Projectile motion, section 6.1. So what again is projectile motion? Do we know?
It's where it starts out and it goes like that.
Okay. So
Like
give me examples when it goes through projectile motion.
A
A baseball, right? When you throw a baseball, it goes through projectile motion, right?
A basketball.
A basketball, right?
A bullet.
A bullet.
Soccer ball.
A frisbee.
A
Football.
frisbee.
Shrapnel.
Shrapnel. No.
Mr. Linker talked about this last.
What did I just draw here? Angry Birds, right? Angry Birds is a perfect example of projectile motion.
Can we play Angry Birds?
Okay. So here's my slingshot, here's my bird, there's my pig. The pig's happy right now. Okay? But when you play Angry Birds, something gets launched, and a bird gets launched out of the slingshot, right? And it follows that path, right?
Not if he's a special good.
Right? It follows that path, right? The angry bird is the projectile, it's the thing flying through the air. This green thing is the, anybody want to know what it's called?
Projectile.
This is projectile motion. That is the trajectory. Okay? The green line there is the trajectory. It's the path it follows. The projectile is the thing going through the air. The green path is the trajectory. Now, if you are good at Angry Birds, the bird will travel in both the X direction, right? And the Y direction. Right? Now, as I pull down on this slingshot, if I pull back more, right, the bird will get launched with a higher arc, right? Right? Gets launched with a higher arc. And that higher arc has more Y and less X. Okay? So the angle, which what we were just working on a second ago, the angle at which we're launched at changes our X and Y, right? Bigger angles mean more of our velocity goes to Y, less of our velocity goes to X. Does that make sense? Okay. So this, what's going on in Angry Birds is projectile motion. Right?
So is there an exact definition for that?
What? For projectile motion?
Do we have to know?
However, the space one.
I didn't write down a definition of projectile motion. Right? I just think of projectile motion more as examples. I mean, the book probably has a set definition, but anytime something is flying through the air, that's projectile motion. So like a golf ball sailing down the fairway. Okay? Hopefully it's sailing down the fairway. For me, it's more going into the rough. Okay? A baseball being thrown, an angry bird being launched. Okay? A ball rolling off a table. Okay? Your pencil falling from the table to the ground. Right? All that is projectile motion. Okay? Anytime something goes through the air, it's projectile motion. I'm not even going to say anytime something goes in two directions through the air is projectile motion. Okay? But anytime something goes through the air is projectile motion. Yes, Mr. Linker, if you had Mr. Linker for physical science last year, he probably showed you this. If you had me for physical science last year, he probably showed you this.
Yeah, both.
If you went to a different school last year, you've probably seen this before. This is a very typical demonstration for what we're going to talk about. And a lot of science teachers like to bring this up.
They hit the exact same time.
Now, the reason being, and I'm intentionally standing behind my desk because whenever I do this, people try to look at it and say, oh, this one hit first. I know because I saw it. Well, when I'm back here, we're going to hear a noise, right? We're not going to see the balls hit. That noise is going to indicate which one hits the ground first. So what's going to happen here, okay? When I flick this red lever, it's going to launch that ball. Okay? Also, when I flick this lever, it's going to drop this ball.
That one's good.
Right? Now the question is, which ball hits the ground first? If you know the answer for definite, please don't shout it out.
I know.
But the question is, which ball hits the ground first? Okay? Does the one that's dropped hit the ground first?
Yeah.
Does the one that's shot hit the ground first? Or, there might be a third option. Okay. Who thinks the one that's dropped hits the ground first?
It is.
Who thinks the one that shot Instagram first? Okay, what's the third option?
They both
Same time.
simultaneously.
Simultaneous. Lynn, you said the drop when it hits the ground first. Why?
I feel like the angle is less than
There's no angle, right?
well, it looked like that.
It might have been because I was holding it kind of. Not level. I wish they put a little level bubble on here. Okay, so you think the angle's less, right? You're probably thinking, and I'm speaking for you, so if I'm wrong, let me know. All right, that shortest distance between 2 points is a straight line, right? Right?
Yeah.
This quickest distance down is straight down, right? Right? Does that kind of what you're thinking?
Yeah, it's
Okay.
like
This one's going off in that direction somehow, right? Tim, why'd you say this one? Yeah. No one raised their hand? Okay. Typically people say this one because it has initial velocity. Whoa, there we go. That one will hit the ground first if I do that. All right. Is that this one gets shot so it has more velocity to get started, right? Right? Now if I'm holding this completely level, this velocity, is it horizontal or vertical or both?
Horizontal.
Horizontal. Right? Okay. So, let's drop it, guys. Ready? Now, listen. 1, 2, 3. Left, you couldn't even see it. You heard it. How do you know it's the left one?
It was the left one.
It was the left one?
They had to be at a certain level for it to hit at the same time.
Okay. Who says they hit the ground at different times? Okay. Who says they hit the ground at the same time? Who's inconclusive?
I think we should all close our eyes and just like listen.
Kevin is inconclusive.
All right, we'll do it right here so you guys can watch. Actually, I need to turn this way. Okay.
You're cheating. Look at the
I
ball.
really got a little nervous.
Branch might be set it on
You guys
table.
ready?
Yeah.
Set.
You see, the
Oh,
left
get
one
my
hits
foot!
first.
Wow.
The left one hits first.
At the same
Branch, set it on the table, dude.
Okay.
It might work better. You're not very level.
I'm not level.
Yeah, Laker had it on Monday.
I am kind of unstable.
We see that.
Okay, you guys ready? Set. Hopefully I don't hurt my fingers.
Stay. There you go.
How many hits did you hear?
2.
You heard 2 because it bounced.
Yeah, you heard 2
No.
because it bounced.
No.
But the first hit was at the
Exact same time.
same time. Okay, so in this projectile motion, the object's traveling in the x direction and the y direction, right? Right? Just like when I have the shoot a ball, drop a ball situation.
Oh,
This ball gets shot, right? Right? That ball gets dropped, doesn't it? Okay, yes.
That's kind of like an Angry Birds. There's this bird that like breaks up into other little birds, and it's like if you think about it, they all hit at the same time.
No, they don't.
No, no.
They don't.
They don't.
If you shoot it straight,
No.
You want the bluebird?
Yeah.
the little blue bird,
that breaks up.
because when it breaks off, the first one hits.
When it breaks apart, they get some velocities in the horizontal. The bottom one has a downward velocity in the y direction. The top one has an upward velocity. The middle one stays on the original path.
But they don't hit the.
They don't always at the same time.
Am I right?
Okay, no,
No, yeah.
I'm sorry.
Alright.
There are some ways you can make them at the same time. They'll hit if you shoot them at an angle and they're hitting something that's staying here a certain x distance away. Typically they'll hit at the same time if the angle's low enough, which is probably what you're doing. If you shoot a low angle like this and you explode them like right here, then they'll hit at the same time because they're just too close. Explode them earlier. Like shoot them at a steep angle and explode them earlier, and you'll see that they don't hit at the same time. All right. All right. So
Black, so it doesn't-
when I shoot a ball and drop ball, Emmett, the green ball is the drop ball, the black ball is the shot ball, right? Okay. What's the initial x velocity for the green ball? 0. What's the initial x velocity for the black ball?
I have no idea.
Okay. Is it 0? No. Right? Okay. In the y direction, what's the initial velocity for each of these 2 balls? 0, right? But they have a, in the y direction they have a gravity, right? Gravity is an A.
Acceleration.
Acceleration. I guess I should have said Ian. Right? They both have an acceleration, don't they? Right? Which way is the acceleration? Down. Okay. Now, since these two balls are shot and they have the same acceleration in the y direction, as they go, well, I guess I should have done that in green. Sorry about that. As they're dropped and shot, okay, they will travel the same vertical distance in the same amount of time, which means they hit the ground at the same time. Watch your mouth, Julian. Okay? Alright. So they travel the same vertical distance in the same time. Right? And they both had no initial Vy equals 0 for both of them, right? Right? Right, guys?
Yeah, did you show
Acceleration for both is 9.8.
Brent, did you show Ghostbusters for this last week?
Yeah, that was the shoot a penny, shoot a ball, drop a bullet. Yeah. I'll put it on the press. We might watch it on Monday. All right. So the drop ball and the shot ball will hit the ground at the same time. Okay. The reason being is this x component of velocity has no effect on the y component of velocity. Okay. Let me say that again. The x component of the shot ball's velocity has no effect on its y component. All right, does that make sense? All right. So things traveling horizontally do not affect things traveling vertically. Okay? So horizontal motion does not affect vertical motion. Yes, Richard?
But if you have like an airplane that's diving straight down and like a glide airplane, it would take longer for that one to reach the ground, right?
Right. Because the one diving straight down probably has the engines are probably still going, which increases velocity as it goes down. So it would be accelerating faster than 9.8.
What if it just free fall?
It's just free fall? Okay. Well, airplanes too are kind of running into a situation where you have a lot of air resistance, right? They're really high up in the sky, they're really big objects, right? So they may not, the one that's falling straight down, air resistance is kind of working in its favor. The design of the airplane is working in its favor. It's designed to go nose first, you know? The one that's gliding is not going nose first. The wings are catching a lot more air. So air resistance plays a role in that one. When air resistance gets involved, then things change, right? But like in Angry Birds, like what we're going to handle in this class, like a lot of projectile motion you guys deal with, you know, like playing baseball, playing basketball, playing whatever sport it is you play, all right? Things falling off the tables, air resistance will have very little effect, all right? When we start getting to big situations like, you know, like spaceships coming back in from orbit, right?
A lot of air
Then air resistance plays a big role.
and the ozone.
What?
And the ozone.
And the ozone, well, in the density of the ozone, because that changes your air resistance. All right. So, what this shows me is that the x direction, okay, the x direction, velocities, accelerations in the x direction, horizontal direction, and the y direction, velocities, accelerations, and so on. So the x direction and y direction are independent of one another. So what that means is my x velocity does not affect my y velocity. Okay? My y acceleration does not change my x velocity. Okay, does that make sense? Lynn?
So you're saying that they both travel the same vertical distance?
Yep.
But then this one isn't it less than the
The overall distance.
Oh.
Like if I did something like this, because this one's kind of traveling around my hypotenuse, right? This one covers more distance in this way. But vertically, from here to here, they cover the same distance. Okay, does that make sense?
Because this look like it's traveling more.
Well, it does show more distance. This length is longer than this length. But I'm not worried about, because this, if I follow this path, right? Is that just in the y? Is that just vertical? This has some horizontal aspect to it, doesn't it? Okay, does that make sense?
So it does affect from the horizontal.
No, the horizontal velocity is unaffected. Okay? This path is longer. This ball has a greater total velocity. But that's including the x and the y. Okay? The y velocity, the y acceleration, does not affect the x velocity. Now the total velocity is affected because that contains both x and y. Okay, does that make sense? But the y direction is not affected by the x direction. And the x direction is not affected by the y direction. Okay, does that make sense now? Okay. Any other questions? Any other questions, guys? Okay.